Welcome to the Walton Pi. Today we're going to be talking about how to find the area between curves. So an important interpretation of the integral in order to find the area between curves is that you can think of the integral of a function as that it gives us the area under the curve. An important nuance here is that if the curve is below the x-axis, then that area is negative. So below the curve means from the curve to the x-axis. So if our curve was this bottom curve in this shape, then the area under the curve, so the area between the curve and the x-axis, that is considered negative. So that is something that you have to pay attention to if you're ever asked to find the area rather than just the integral. So if we are trying to find the area between two curves, we can subtract the area under the bottom curve from the area under the top curve, and that'll give us the area between the two curves. So if this was our diagram that we are trying to find the area between the curves, we can take the top area and subtract it and then subtract the bottom area. So if we were to look at what happens in these different pieces, in those two spots where the top minus the bottom is going to cancel out, and then the subtracting negative area in this bottom part is going to be adding the same thing as adding positive area. So once we've done that, that's going to give us the area of that region. So since we can find the area between two curves from subtracting the area under the bottom curve from the area under the top curve, this gives us a nice form that we can always use to find the area between two curves. We can integrate from a to b, so start to finish, of the top function minus the bottom function, and then with respect to whatever variable we have. So let's do one example together. Let's try and find the area between the curves x squared minus 6 and y equals 3x minus 2. The first thing we need to do is we need to find where the curves intersect. So we need to find our bounds of integration. If we set the two equal to each other, we get x squared minus 6 equals 3x minus 2. So that becomes x squared minus 3x minus 4 equals 0, which factors as x plus 1 times x minus 4 equals 0. So that means that x is either negative 1 or 4, and those are going to be our points of intersection. So our bounds of integration will be from negative 1 to 4. Now that we know our bounds, we need to figure out which function is the top function and which function is the bottom function. So to do that, since x equals minus 1 and x equals 4 are our only points of intersection, we can just plug in a value between them to figure out which function is on top based on which function has a larger value when we plugged in that x value. So let's plug in x equals 0 into both functions, since 0 is between negative 1 and 4. That's going to give us y equals x squared minus 6 gives us a value of negative 6, while 3x minus 2 gives us a value of negative 2. Negative 2 is bigger than negative 6, so that means that 3x minus 2 is our top function. If we plug all of that into our form, so we have the integral from start to finish of top minus bottom, that becomes the integral from negative 1 to 4 of 3x minus 2 minus x squared minus 6. If we integrate that after simplifying, that becomes the integral of negative 1 to 4 of negative x squared plus 3x plus 4, which becomes negative x cubed over 3 plus 3x squared over 2 plus 4x evaluated between negative 1 and 4. So plugging all of that in, it's able to reduce down to 43 over 2, or 21.5. So that tells us the area between the curves 3x minus 2 and x squared minus 6. The area between those two curves is 21.5 of whatever our units would be. I hope this video was helpful. Please check out some of my other videos, and please like and subscribe if you haven't already so I can continue to make these sorts of videos. Have a great day, and good luck with the rest of your math.